Okay, welcome to day 2. We're going to work more on related rates, more word problems. This is why we do calculus, to understand how it applies to real life applications. So when I take this derivative, because it's a ddt, I always have an extra little thing at the end. So this is going to be 12x squared times dx over dt, 24y to the third times dy over dt. And if I rewrite this guy as 5r to the half, its derivative is 5 over 2r to the negative 1/2 times the dr over dt. And if you want to use shorthand for all this stuff, you can call this 12x squared times x prime, 24y cubed times y prime, or 5 over 2r to the negative 1/2 times r prime. So today's lesson we're going to work more on these real life applications, but I came up with a little acronym to help us figure out what we should be doing. DREADS, where we either take the given diagram where we draw a diagram and we put in the information that's given to us, including identifying which are the rates. Anything that's up with the word per is going to be a rate. Then we write out a general equation, whether it's a Pythagorean theorem or an area or a volume, whatever type of equation we're dealing with. We take its derivative, or its ddt, of that, and then we substitute in all the given information that we have, and we're able to solve the problem. So as you can see, I kind of have my diagram already here. I have a ladder, a 3-meter ladder leaning up against a high wall. The foot of the ladder moves outward at a speed. Sounds like a rate. 0.1 meter per second, definitely a rate. When the foot of the ladder is 1 meter away from the wall. At the moment, how fast is the top of the ladder falling? So right now, I know this side, I'm going to call that hypotenuse side z. I know that is 3. So since it's 3, I know that x squared plus y squared is equal to 3 squared, or x squared plus y squared is equal to 9. That is the Pythagorean theorem. Okay. What else do I know? Well, I can put 1 in here and solve for y. So when I do that, I get 1 squared plus y squared is equal to 9. Y squared is equal to 8. Y equals the square root of 8. So I have a diagram right now. Not to scale. I know x is equal to 1. Y is equal to the square root of 8. And z is equal to 3. That's what I know as far as the sides. Do I know any rates? Well, let's see. I think we were told that x prime was equal to, because it is moving out this way, and we're going to learn that to the right is positive, to the left is negative, up is positive, down is negative. This guy is moving down, so this is 0.1 meters per second. And this y prime, how fast is it moving down? I don't really know that right now, but I do know something else. I'm going to come back to it in a second. So I'm going to keep my diagram here. We've already established that the derivative of the Pythagorean theorem is going to be x times x prime plus y times y prime is equal to z times z prime. Okay, z prime is dz over dt, and this is the rate of the change of the ladder, because the ladder is side z. Well, the ladder is always 3. So side z is equal to 3, and it's constant. It never changes. The ladder doesn't change length. It's not a collapsible ladder. So z prime is equal to 0. So z prime here is equal to 0. So when I fill in with what I know, well, this is what I know. I know this is 1 times 0.1 plus radical 8 times y prime is equal to 3 times 0. So right now I have 0.1 is equal, plus radical 8 times y prime is equal to 0. I bring this over to the other side. I get radical 8 times y prime is equal to negative 0.1. I divide by square root of 8. And I get my dy over dt, or my rate of change of my y side, the vertical side, is equal to whatever this decimal is in your calculator. I put it in, I get negative 0.035. And let's see, my units were meters per second. It is negative because that side is falling down. Okay? Start off with our formula, take its derivative, we plug in what we know, and we find out what we're trying to find. Well, what if the ladder had been 2 meters away from the wall instead of 1 meter? So that means this x is equal to 2. My x prime is still equal to that 0.1 meters per second. My y prime, I don't know right now. My z, my ladder, has not changed length. And my z prime is still 0 because the ladder length is not changing, it is constant. So if I go back to my Pythagorean theorem of x squared plus y squared is equal to 9 for this particular ladder, and 2 squared plus y squared is equal to 9, I get y equals the square root of 5. So I know that y is equal to the square root of 5. The only thing I don't know is y prime. That is unknown. So going back to x times x prime plus y times y prime is equal to z times z prime. I get 2 times 0.1 plus square root of 5 times y prime is equal to 3 times 0. And I get 0.2 is equal to 0.2 plus square root of 5y prime is equal to 0. Or I bring it over, I get my dy over dt, which is my y prime, is equal to negative 0.2 over the square root of 5. And I put that into my calculator. I get negative 0.089 meters per second. Now here's what you have to recognize, that this rate of change of the x side did not change, it was still 0.1. So x prime was the same, but y prime increased in speed. I know it's more negative, but its speed increased. It's falling down, that's why it's negative, but yes, it was falling down faster than it was before. It's an interesting observation. Okay, and observer is 4,000 feet away from a launch pad to watch our rocket launch off. The rocket blasts off and maintains a velocity of 1,000 feet per second. Ooh, velocity, 1,000 feet per second. Sounds like a rate. How fast is the observer to the rocket distance changing when the rocket is 3,000 feet above the ground? So I have 4,000 feet, 3,000 feet, 1,000 feet per second. I'm going to draw a picture. So I've drawn my picture right now. I know my observer is 4,000 feet away from the base. Here's my right triangle. The rocket's 3,000 feet above. I don't know how far the distance is. I don't know how far this is right now, this purple side I'm drawing. But I know Pythagorean theorem that 4,000 squared plus 3,000 squared is equal to z squared. If I go, it's a 3, 4, 5 right triangle, so I get z is equal to 5,000. So this is 5,000 meters. Now I could use my Pythagorean theorem of x times x prime plus y times y prime is equal to z times z prime. Let's see. X prime is the rate of change of the horizontal or x side. Well, that is 0 because this 4,000 feet, this guy is not moving. He is constantly 4,000 feet away from the base. My y prime is the rate of change of the vertical side, which is what the rocket is doing. That is 1,000 feet per second. My z prime is what I don't know. Substitute all this in here. 4,000 times 0 plus 3,000 times 1,000 is equal to 5,000 times z prime. I get, 3 million equal to 5,000 z prime. And I get my rate of change of my z side, or my z prime, is equal to 600 feet per second. So this distance, this purple side right here, between the person and the rocket, is changing at 600 feet per second. Okay, let me go on to the next problem. See if I can get out of this for a second. Okay, I have a girl flying a kite at a height of 300. And the wind is blowing at 25 feet per second. How fast must she let out the string when the kite is 500 feet away? Well, we're going to draw out the problem, and we're going to see what we know and what we don't know. Well, let's see what I know. It says she's flying a kite at a height of 300 feet. Well, that's side Y. That goes 300 here. The wind's carrying horizontally away at 25 feet per second. 25 feet per second. That sounds like a rate. So the wind is blowing this way, so that's the x prime. That's 25, blowing it away at 25. How fast must she let the string when it is 500 feet away? So that's the string side. The string is right here, so the side z is 500. Well, right now I don't know side x. So obviously I can do x squared plus 300 squared is equal to 500 squared. And again, by Pythagorean theorem, I have x is equal to, it's a 3, 4, 5 right triangle, so this is 400 feet. This is what I know now. Now, let's talk about y prime and z prime. I'm trying to find out z prime. How fast must she let out the string? So this is what I'm looking for. This side here, y prime is equal to 0 because it is at a constant height of 300 feet. So my Pythagorean theorem, derivative, I think we've covered today. So it's going to be 400 times 25 plus 300 times 0 is equal to 500 times z prime. I get 10,000 is equal to 500 z prime. Divide by 500. I get dz over dt, which is z prime, is equal to 20. And the rates is feet per second. So, in this pretty heavy wind of 25 feet per second, she's got to let out the string at 20 feet per second to keep up with the wind. Okay, we're reading through this problem. We have a gas station at a corner of a north, south, east, west road. A police car is traveling toward the gas station from the east. That means he's going west, chasing a stolen truck, which is traveling north from the gas station. The speed is 100 of the police car is 100 miles per hour when it's 3 miles from the gas station. The truck is 4 miles away, going 80 miles per hour. So I want to know how the distance is changing. So I'm going to draw this out. So here we go. I've drawn out the picture. Here's my gas station at the corner. I decided to make triple the owner of the gas station, so we have max gas right here at the corner. The truck is going away this direction, so going up is a positive direction. We know the truck is, the truck is 4 miles going 80 miles per hour, so the truck is at 4 miles and its rate is 80 miles per hour. Now the car is going this way, so the car is 3 miles away, but its x prime is negative 100 because it's going left. I could do with the Pythagorean theorem, 3 squared plus 4 squared is equal to z squared, so I get z is equal to 5. The only thing I don't know is z prime. So again, my Pythagorean theorem, x times x prime plus y times y prime is equal to z times z prime. So 3 times negative 100 plus 4 times 80 is equal to 5 times z prime. Negative 300 plus 320 is equal to 5z prime. 20 equals 5z prime. So the rate of change of this distance, this diagonal distance right now, if you draw diagonally, right now the car to the truck is 7 miles away, but if you draw a diagonal distance, z prime is equal to 4 miles per hour. That's how it's changing in the moment. So in other words, it is increasing. Even though the cop car is going faster than the truck, the distance between them, that diagonal distance, is increasing because z prime is positive. So what would happen if I change my condition and I said the truck is going 70 instead of 80? Well, everything's going to be the same. So it's going to be 3 times negative 100 plus 4 times 70 now equals 5 times z prime. So negative 300 plus 280 equals 5z prime. Negative 20 equals 5z prime. So my rate of change, my dz over dt, or my z prime, is going to be negative 4 miles per hour. So the distance is now decreasing because z prime is equal to a negative. So reading through this problem, we have a balloon that is rising rising vertically at a rate of 1 feet per second. Ooh, a rate derivative. I want to know what's going on that when the balloon is 65 feet above the ground, a person on a bicycle goes underneath it, riding at 17 feet per second. I want to know what's happening after 3 seconds. So at 3 seconds, I have the bicycle. Well, its distance is going to be, let's see, 3 times 17, I'm going to have 51 feet is the distance of the bicycle. And the balloon, its distance is going to be the original 65 plus the 3 times the 1 feet per second to give me 68 feet for its distance. So I can draw this picture. Well, let's see what I know. I know at the moment the bicycle is 51 feet and its rate, it is moving at 17 feet per second. At the moment, the balloon is 68 feet and its rate that it's rising is 1 feet per second. So I don't know z. I don't know how far this distance is. I'm trying to figure out what this distance is. Well, by Pythagorean theorem, I could do 17 squared plus, excuse me, not 17, my bad. 51 squared plus 68 squared is equal to z squared. It's still a ratio of 3, 4, 5 right triangle, so I get z is equal to 85. When you do the Pythagorean theorem correctly. So the only thing I don't know is how is this distance changing between the bicycle and the balloon. And of course, I could do my Pythagorean theorem, x times x prime plus y times y prime is equal to z times z prime. I have 51 times 17 plus 68 times 1 is equal to 85 times z prime. I get, let's see, 867 plus 68 equals 85 times z prime. 935 equals 85. Wow, that's pretty messy. 85 times z prime, I divide by that. So I get my rate of change, or my z prime, is equal to 11 feet per second. That's how the distance, this diagonal distance between the two, is changing in the moment. Okay, thanks for watching.